dear students. I am S. Kishore, physics teacher. Today I am going to talk about on the first lecture about numerical problems on circular motion, and is very conceptual question. And such type of numerical may be asked in the examination, and is very important concept rather than the questions. That's why you should concentrate your mind towards the question. And the question is: the pendulum consists of a sphere of mass m suspended from a point on a ceiling with a wire of length L. The breaking strength of the wire is 2 mg. Then what is the maximum angular displacement can be given to the pendulum? Okay, the question is telling you this is a pendulum consists of a sphere of mass m, right, suspended from the point of a ceiling with a wire of length L. You are looking, this is a wire of length L, OB is a wire of length L and is connected with the sphere. Okay, connected with the sphere. This is initially at point A, and the breaking strength of this string is 2 mg given in the question. Then what is the maximum displacement can be given to the pendulum? Okay, so what is the maximum displacement given to the pendulum? That we have to find, means maximum angular displacement. And in the figure you are looking, the maximum angular displacement is suppose theta as it moves from the position A to the position B. That's why as it moves from the position A to the position B in the diagram all of you are looking, then it gains some sort of height am. You are looking am, the some sort of height is this here, because look at here, this is actually this is the point O, and this is supposed to be the length L of the string, okay, and when it is displaced by some sort of angle, then it gains some height. We suppose this height it gains some sort of height, and this height is supposed to be h, and this is the point A that is shown in the diagram. Okay, so as it moves from the position A to the position B, from the position A to the position B, then it gains some sort of height. Suppose this is point C, AC, it gains some sort of height AC. But you are looking here, we have already supposed here M, then it gains some sort of height M. Okay, but as it moves from the position A to the position B, then actually the kinetic energy it has at the point A is converted into potential energy. Okay, because of gain of this height h. So if we suppose the velocity at the lowest position where the breaking strength is given 2 mg, this is the breaking strength given 2 mg, then the kinetic energy it gains suppose half mv square. Kinetic energy, this kinetic energy is converted into really potential energy. This is converted into potential energy, and this potential energy is supposed to be mg, and this is h. Okay, mgh is there. So on this principle we can find the angular displacement that is given to this pendulum from the position A to the position B. So we have to find this angular displacement. But the complication is that to find the value of h, you are looking here, to find the value of h in triangle is here, in right angle triangle we can use OMB right angle triangle. So as we define cos theta, then cos theta will be equal to b by h. So as we take it here, cos theta is equal to b by h, that is OM over h means actually OL. So OM can be defined, and this OM will be equal to L cos theta, and by the help of this length OM we can find the height gained by the sphere of mass m from the position A to the position B. So what is the height it gains from here? That height can be found from like this. This is OA minus OM, and OA is equal to L and OM is equal to minus L cos theta. So L is common factor, so what you can write, 1 minus cos theta can be defined. In this way we can define the height the sphere can gain as it moves from the position A to B. Okay, and by the help of this relation, half mv square is converted into the potential energy mgh, we can find the value of what? Theta. Okay, so the complication is breaking strength is there. So the maximum tension in the string is also known as breaking strength, and you are looking the maximum tension in the sphere will be at point A, or at the lowest position of this sphere. Okay, so the given parameter is, there is a sphere of mass m, mass of the sphere, suspended mass of the sphere is given, suspended mass, this is suspended mass is equal to m of the sphere. This is of the sphere is given, and from the point on the ceiling, look at here, the suspended point from where, suspended point of the ceiling is O here, and length of the, by the length of the wire is L. So this gives the radius of the sphere. So radius of this sphere is, radius, you are looking, radius is equal to L, that is length of the wire, is there, and maximum tension means breaking strength. Breaking strength is given, breaking strength is given in the question, and this breaking strength is equal to T max, and T max is at the lowest position A. It is clear, at the position A. So this value is given in the question, that is 2 mg. Okay, but at the lowest position of the sphere we know that T max at the lowest position is actually mv square by r, plus mg. Okay, and T max is given here, and this T max is given in the question, which is equal to 2 mg is equal to mv square, and r is actually L. So this is plus mg, or we can write 2 mg minus mg is equal to mv square by L. So what you can write it here, mg is equal to mv square by L. So this m cancel out, and this implies we can write v square goes to gl. Okay, v square goes to gl. It is clear. So as V square is equal to GL by the help of the concept of maximum tension or breaking strength at the lowest point of this sphere. Now as it moves from the position A to the position B, from the position A to the position B, so what we can say it here, look at here on the diagram. First of all, we defined all this, and then we found the value of V square. We found the expression of V square on the basis of the breaking stress or maximum tension at the lowest position. Then on the basis of the concept of conversion of energy, as it moves from the position A, from the point A to the point B, the kinetic energy changes into potential energy. Means kinetic energy converted into potential energy for the position B. So the height it gains can be found. Gain गरेको height हामी निकाल्न सक्छौं. त्यसकारण as it moves from point A to the point B, we can write the loss of kinetic energy is equal to gain of potential energy. Okay, loss of kinetic energy is equal to gain of potential energy. Loss of K is equal to gain of PE. We can write gain of potential energy. So loss of K means the kinetic energy at A is half mv square. Half mv square is this, and that is equal to potential energy mgh, and h we can find by this manipulation. First we found the value of OM, and as we subtract OM from OA is equal to L in the sphere. OA चाहिँ OB को बराबर छ, स्ट्रेंथ यो वायर को लेंथ को बराबर छ, जसले गर्दा OA बाट हामी यो OM घटायो भने we can find the height it gains, है. B point मा कति हाइट गेन गर्न सक्दछ त्यो कुरा हामी डिफाइन गर्न सक्छौं. अनि हाइट डिफाइन गर्न सकेपछि we can find the actually angular displacement can be given to the pendulum. What the angular displacement that we have given to the pendulum can be determined on the concept of this loss of K is equal to gain of PE. So half mv square is equal to mg, and h can be found, just we have determined here. हामीले यहाँ निकालिसकेका छौं. यो loss of K is equal to gain EP गर्नुभन्दा पहिले L into 1 minus cos theta. So we can write L times 1 minus cos theta यसरी हामी गर्न सक्छौं. अब यहाँनिर के देखिरहेका छौं त हामी, यो m ले यो m क्यान्सल गर्न पाइन्छ. अब यो क्यान्सल गरेपछि हामीले यो भन्दा पहिले V square डिफाइन गरिसकेका छौं. that V square is equal to हामी डिफाइन गरिसकेका छौं GL. So what you can write half into GL यहाँ लेख्न सक्छौं. V square हामी पहिले डिफाइन गरिसकेका छौं. V square is equal to GL by the help of the maximum strength or breaking strength, maximum stress or maximum tension or breaking strength. We have already determined the value of V square. Expression of V square is GL, and then on the right hand side फेरि GL नै छ, 1 minus cos theta हुने भयो. अब यो GL ले यो GL हामी हटाउन सक्छौं, क्यान्सल गर्न सक्छौं, जसले गर्दा half is equal to 1 minus cos theta हुने भयो। अब यसरी यो म्याथमेटिकल म्यानिपुलेसनबाट क्रिस्टल के क्लियर भइरहेको छ, व्हाट यू क्यान राइट, और यो cos थीटालाई हामी लेफ्ट ह्यान्ड साइडमा लगायो भने राइट ह्यान्ड साइडमा 1 माइनस हाफ भयो। सो cos थीटा इज इक्वल टु हाफ। अब यो cos थीटा हाफ भइसकेपछि हामी के पायो त, और cos थीटा इज इक्वल टु cos 60 डिग्री हुन्छ। cos 60 degree, this cancel out, so what you can find it here, therefore theta is equal to 30 degree. Okay, means what is the maximum angular displacement can be given to the pendulum as it moves from the point A to the point B. This is the required maximum displacement, angular displacement maximum, which is required maximum angular displacement. Okay, this is your answer. In this way, यस प्रकार यो पेन्डुलम को केसमा र ब्रेकिङ स्ट्रेन्थ दिएको केसमा हामी लोएस्ट पोजिसनबाट भर्टिकल सर्कलकै कन्सेप्टको लोएस्ट पोजिसनमा जुन हाम्रो टी मैक्स आइरहेको छ, त्यो टी मैक्स नै हाम्रो ब्रेकिङ स्ट्रेन्थ हो। एज वी एक्सिड द टी मैक्स, देन द स्ट्रिङ or wire will break there. That's why this is the limitation of the breaking strength or the tension at the lowest position, which is given, which is 2 mg is given. Okay, so on the basis of that concept, breaking strength or maximum tension, first we found the value of v square at point A, and as it moves from A to B, we can use the concept of loss of kinetic energy is equal to gain of potential energy, and then we form the value of H it gains as it moves from the point A to the point B, and put the value of H, and after mathematical manipulation we can easily find this value. Okay, the maximum angular displacement that we can given as it moves from the point A to the point B. यसरी हामी यो थीटा को भ्यालु यानी दिस इज द एंगुलर मैक्सिमम एंगुलर डिस्प्लेसमेंट निकाल्न सक्दछौं। ओके, सो यू कैन actually think once and then proceed it by doing some sort of practice for this problem, and the concept will be built up in your mind, and you can easily tackle this such type of question in the examination easily. Thank you very much for today.